And welcome back. This is our second video of however many. We don't know. Going to be lightweighting, continuing with the lightweighting effort on this. This should start to become faster and more straightforward videos. Previously, we had some results from our simulation. We can have a look just by clicking results, come back. If we haven't done anything, we'll just see the previous. Now, you can see here that our whole, this is safety factor. No surprise, it's all right around the top here where the flow lines, if we want to think of it that way, would be compressed by the part. What we notice is, interestingly, that there's almost no, no real stress compared to everything. It's all safety factor 8 plus up here. So maybe this whole thing is kind of peripheral or extraneous. We see some lower safety factors down at the bottom of the stub shaft, or the, what are we calling it here, the stud, where it's been compressed or pushed up against the housing down here at the bottom of its mount point. And we see the standard, as we would expect, bending in here. So we've got this empty gap. Let's have a look at stress. If we pull our stress down, oh, not this way, pull our stress around, we should see there's the bending happening. So a little bit of bending in the stud, mostly in the back of the hanger. Now, we're going to be talking in these videos about two things. One, lightweighting, which is to get rid of some extraneous material, and then two, equi-strength. One of the problems we're having here, just turn off our slice, is we've got quite a bit of stress held by the front face of this like wider hanger here. Part of the hanger, and it's all concentrated in the back of this rib. So let's go at this kind of methodically, but we're gonna, we have infinite ways to solve this in a way, or lots of ways. We're gonna try and stick with something quite straightforward in this one. So we're gonna go back here and cut this away. So that's the plan, and my proposal right now is that this giant lobe is not required. It makes if we were machining this, which we're not, this is probably a casting, would give us a bigger chunk of material that has to be started with. It's also just extra material in a casting if we're using a casting. So arguably, we should try and minimize this and see if we can shift some stress up into more material so that we're using it, more even sustainability wise, we're being more sustainable by having more strength being spread, or more stress has been spread out over the part, and not having so much extraneous useless material. Second and last, just before we get started here, we see a little tiny bit of stress here, and kind of worried about what is causing that. Maybe this lump of material here, again, like patching your umbrella with a car tire, this might be actually creating an unneeded stress. So I've got two plans here. Going to decrease this lobe and maybe see if I can start getting at this part as well. So when we're doing these sort of lightweighting things, when we're not just using some blind algorithm, we're doing this knowingly as people, I hope. So let's see if we can kind of keep an eye on two things at a time. So we'll kind of go at it almost like a superposition effort. Let's go back to design. Maybe click it. We might be able to do this one easily. So let's kind of say, okay, well, that's it for the setup and the history. So I'm going to go ahead and start doing new things here. So let's go into the hanger component and see if I can just, for example, delete these guys. What happens if I just press delete? Oh, well, that's kind of good. So that's not bad at all. So let's go with that. So we can see here the previous stuff from the previous video. Now we're just kind of working our way through SolidWorks style. This to me is a tertiary thing. So I'm going to also show myself that I'm starting anew here with a sketch. I'm going to use the sketch in the component, or sorry, a sketch in the component face, and I'm on the Z, Y, or YZ again. Let's do a slice. And if things are getting in the way, because we don't really need all this other stuff, we can also isolate. There we go. So that's all good. So we can kind of see what's going on here. Now, all I want to do is maybe delete things out. So I've got this problem here. So one way to do this is to try and modify what we've got, which is problematic. Or maybe we should just cut that all off and start again. So let's try that. Now, one thing I do want to know is the width. The length of that's 3/8. Let's try, let's make sure we've got the whole thing there. Yeah, so we've got 3/8 for the width of this, so we'll keep that in mind. We also had 1/8. I'm writing these down. So the web is 3/8. We can do parameters if we wish. So let's do that. So change parameters. I'm just going to add some here. So fillet, and we'll call it standard fillet. 1/8. We'll also go for web or NWT. Well, web NWT. Let's go for NWT web, which of course is kind of an oxymoron, but whatever. 3 divided by 8. Okay, so now we have those. We can delete at our leisure. So got this sketch. What I would like to do is get a good projection. One of the disadvantages of what we're about to do is we have to kind of overlap. So if we go to the very tip of this, we'll have a gap. So this is kind of pleasant. We can use this as a projection. So let's actually just project the whole thing. Either one is fine. So let's project that. Yes, project, if I could spell project. What we notice is it goes slightly inboard. This is good. So this is what we want. Now we can just do a slice and see what we have. Now, what I'm going to do here is kind of cheat a little bit. I'm going to make, can hide the body if we want. I'm going to make these construction. Now, don't have to do everything. Maybe, like for example, these two guys could be construction. We lose our profile, but we do have a goal here, so this is good. Let's go with a line. Don't need to be anywhere in particular to begin with. I'm just going to go up and curve. Oh, curve. Finish. So I'm going to double click to get the whole thing. I don't like this perpendicular to what exactly. I'm going to go for vertical. Make sure I'm looking at it direct. And I'm going to pull over here and attach this, maybe not to the middle. That's fine. Pull this into place. If you want to pull it all at once, double click and you can get it without stretching everything around. So I'm kind of pulling this down, but this is attached to this, so I'm just going to drag it into place. So next I want to keep this, but my mouse is quite sensitive right now. To be honest, I could like lock it into here, but then if we want to just do a cut, then I'm gonna miss that part. So let's just make these tangent. No. Why can't I make this tangent? Because it's not an actual curve, because it's a projected thing. So let's just pull it into place. Let's give it an actual rational size. Oh, there we go. 0.4. It's a little small. Well, it doesn't matter. Maybe it doesn't. Let's go for, do we need to be exactly right on what was there before? Maybe not. One other way to do this, because that's kind of strange and doesn't really conform to maybe some rationalism before. Another way to do this is to say, let's put these lined up. So the old logic, whoever did that, may have had some rationalism for this. So maybe if we line it up, then we can do an inspection to see what that actually is. I'm losing my mouse here. Crate driven, sorry. It's about 0.3977. So not too bad. So we can see there is some rationality perhaps of some sort. So this would give us maybe a good idea. We can delete that one and just change this back to driving and call it 0.4, which is where we just were. But at least we know what we're doing now. Next, I'm gonna lock this onto the arc. And you know, there was some problems up here with a little dart face right at the end. I'm gonna avoid that too. So maybe all I need to do now is perhaps, it might be hard to make this, but we'll try it. See what we end up with. So I'm gonna make those two tangent. And does it let me move it? Yeah. So let's try for something around here, and we'll give it a dimension 2, perhaps. Tight, but not bad. Let's go with 2. Say okay. Show the body. Now, the problem is I want to cut this away. So let's edit the sketch. So we'll call this profile. Cut. Edit that guy. I just want to be able to use this profile as a cut on the outside. Oh, X. And still not seeing the profile. There it is. Nope. So the body's getting in the way. Sketch is kind of there. So can we use that? Yeah, so for some reason we've lost our lines. So finish the sketch. Show the body. Getting some jankiness here. Do an extrude. Get the profile underneath. 2 sides are symmetric. All cut. Now we're going to cause some problems in here, so we'll have to come in here and maybe fix this stuff up. Okay, so do the cut and say okay. Well, it looks good here. Got some extra bits here. Right, so we're going to have to do some little bits of deleting. Let's try a delete here. That's not what we want. So let's try this. Get everything. That's kind of okay, except for this part. So let's go ahead here. And let's also delete that. See if that works. There we go. Now, a little bit of a fix up in here. Got a little cutout from our part. Pick those 2 faces carefully. There we go. Make sure that everything's matching up. It's easy to pick the face and then pick the other face. Make sure there's no sort of strangenesses under here. So there's no undercut anymore. Everything's looking fine. I'm going to try this without a fillet, but I've gotten rid of quite a lot of material here. Also, importantly, this is probably going to be faced off by you know, a milling machine or something, or ground or whatever. This is where everything's going to sit. Don't want to have this flush with that. So one of the rules from Orlov is don't minimize machining length. And the best way is actually to have pads proud of the surrounding web in this case. So it's looking okay. Let's go into the simulation. Now, every time we simulate, we get a save, so we can let it do that. Let's go up to the top level. Everything's looking okay. I'm not seeing any errors down in here. What's missing? Sorry, there's a little feature here. Oh, this back piece. Okay. So we've done 2 things. We're getting this ready for, do we really need that extra chunk there? And we've cut out also a bit of our web. Let's go and do a simulation run. Back to simulation. Mesh goes out of date. Finish results. Mesh is out of date. that's a janky mesh. So let's go ahead here and adjust the mesh this time as well. I'm going to go progressively a little smaller. So for now, let's just try and get it a little tighter. So I'm going to go and make it about half the size. So I'm going down to 5% for now. We may turn this back up later. I've got curved mesh elements, that's fine. Maximum turn angle, let's see how that goes. Let's see, okay. So this is all we're changing for this one. I'm going down to, wait, it should show up pretty well. Okay, don't show us then, 5%. Let's run it again. I don't want to run the mesh too tight at this early stage here, so just easing up onto the mesh. We had some gnarly mesh up here before. This is looking way better. It's a little light here, but that's okay. Pipes looking quite tight already. Might be too much. It's been caused by this, I believe, this part here, but it's just quite solid. It's quite tight for some reason. The stud's looking okay. We've got quite loose mesh around here, so this is too loose. So anyway, let's just try it. We don't have enough mesh here at all, actually. Let's try it as is, see how it goes. And off we go. Make sure you're seeing the correct stuff and solve a study. I usually wait for it to send up, start solving, and then we can go somewhere else. And we're back. Now, you can see here our stress is a little more organized. Let's have a look at our movement here. Displacement 0.2, so we're going to get a little bit more movement, I think. Let's have a look in millimeters. Or sorry, inch. It's up to about 10th out of the bottom. It's not too bad, I suppose. Displacement, let's have a look at stress and safety factor. Safety factor still fairly high, 2.4, wherever that is. Let's have a look. Oh, it's up here where it's being it's in the fastener, so we're not too worried about that. Let's have a look here and remove our extra safety factor, 15 or below. We see here the same behavior as before, but it's a little bit more spread out. This is better. At least I'm happier with this. We can see our web is now more stressed, so it's more equi-strength, it's more used. So this is what we're, for this set of videos, we're saying that's what we would like. We also have we've also removed that sort of localized chunk in a way. Right? So we see it's quite high. We're up here at 6, 7, 6.5, 7 safety factor. So we're not doing too bad. As we go down here, we see the typical sort of bending. It's all in the web now at the low safety factor. Let's have a look at stress. Same argument. Remove the stuff we don't worry about too much. We see typical bending. Let's look at it without any movement. So typical bending, which is what we'd expect. A little bit in the stud, a little bit in the fastener, but nothing serious. So we're looking good. Or at least as we would expect to see things running. But, and maybe this is a but, I don't know if it's a big deal, but we've concentrated all the stress in the web. So we also might be getting a little bit of we're not really analyzing any fillet in here properly, and this is quite a coarse mesh. So on the whole, we're looking okay. The next video will explore tightening up the mesh and having a better look in this area down here, because we'd expect to see probably quite a bit of stress down here at the bottom. We can see this here. So this is kind of a problem. Like, we've got too coarse of a mesh to actually investigate this high stress here at this corner. We would expect to see something here. We have no fillet at all, so our mesh is too coarse. Anyway, that's it for this video. Thanks for watching. We'll come back in the next one, put in some fillets, and increase our mesh density. Over to you.